Well, hello, Brunky Tech. We believe technology is for everybody. We got an intro to our Arduino digital inputs. What you'll need for this tutorial is you'll need an Arduino, you'll need a USB cable, you'll need a breadboard, you'll need a push button, you'll need some jumper wires, and you'll also need some 10K resistors. Because you have to limit the voltage, or excuse me, you have to limit the current going through those microcontrollers. So if you want a better list on things that you need for microcontrollers, I got a video right there for you. First, we're going to understand threshold voltages on our microcontroller. If you have one of these old Arduino Unos R3, these are going to have a voltage threshold of 5 volts. So you cannot exceed 5 volts on this inputs. If you have one of these nanos or a 3.3 volt microcontroller, it's going to limit you to 3.3 volts on the actual input. Now there's also a second thing you got to consider here is on your digital inputs, you have a threshold voltage that turns from 0 to 1. So for this Arduino Uno, I believe it's like 2.3. Actually, I got a setup we're going to look at right now that's going to tell us, but the voltage needs to be at least 2.3 or around there in order for it to read a digital high. So if it's below that, it's going to read a digital low, and there's some hysteria built in there. I'm going to show you how to do that using a voltage divider. Now, if you want more information on a voltage divider, I got a video for you. So first, we're going to set up our code. All right, I'm going to call out a value. Let's call this int value. We're going to set it to 0. And let's see, void setup. We're going to do a serial dot begin. This is so that way we can see what the output is on the microcontroller. And we can see where that threshold switches between 0 and 1. All right. Now, we're going to go ahead and we're going to have pin mode. This is where we actually set the pin on the microcontroller and what it does. So this whole entire void setup is like the starting condition of your controller. You'll want this every time to put it in a specific state when it fires up. So we're going to assign pin mode A1. So if you're wondering what pins you're supposed to use, there's data sheets online that shows you if you can use it as a digital input. I'm using the A1 because it's right there and it's going to make everything easier for me for my entire setup. So usually these are slated as analog inputs, but for our sake, it still does the same thing. So we're going to call this A0 and we're going to call this an input. And then finally, void loop, we're going to pass in this value. And we're going to assign this your digital read of your A0. Now we're going to do a print, serial print, excuse me. And then we're going to say the digital input to A0 is, we're going to leave a space here. You'll see why. Serial print. And then we're going to put LN right here. So that way it passes a new line every single time. And we're going to pass in this value. And don't forget your semicolons. like I always do. So these are here so that way it breaks your line of code. Because otherwise it'll read it as all as one string, and you don't want that to happen like that. All right. Now we can verify our code. It should pop up with any indicated failures. We don't have any. Good job. Now we're going to want to specify our board and our COM port. So our board is Arduino Uno, so that's set up correctly. Now let's take a look at our COM port. Now this defaulted to COM port 12, but I'm actually on COM port 8. So I'll need to pull that up. And then finally, we will pull up this, what are you? Serial monitor. Okay, this is telling you what's going on there. So I'm gonna compile this. You can ignore that, that's from a different program. Now let's upload it. All right. Let's put a delay. Let's put a second delay, and then let's re-upload it. So it runs that loop every single time. It just keeps running it as fast as it can. So if you need to put a delay in there, you can put a delay in there and it slows it down. So that way it only does it. Right here, I put a delay function of 1000, which is 1 second. Now I got my whole setup. I got a digital potentiometer on here, and I am going to adjust it. And when we get above a certain threshold voltage, it'll register a 1 on the screen. All right, there you go. I probably went over a little bit, but now it's registering a 1 on the screen. So if we go down, all right, now we went under 2 and it turned it to a 0. So that's understanding what the threshold voltage is on your microcontroller. All right, now let's talk about simple switches. So I got this guy right here that starts as an open. So essentially, that means you have 2 contacts on there, and then so they're not connected like this. But when you push the button, like so, now it's one clean wire. These are 2 individual wires. They're not connected. You hit the button, like so. Connects like that. So that's what's called a normally open, meaning that there's no continuity through there. And when you push the button, it can close. Vice versa, you can have a normally closed switch. That means you don't have to do anything and it's already closed. You push the button and it'll open it. So there's use cases for both. And if you don't know what you have, let me show you how to do this. So I got this set up right here. I'm using this multimeter. I set it to the resistance measurement right there. And then I have those 2 spots connected right there. So it shows an open load. So it's open right now. So it's open circuit. So once I hit the button, it changes and transfers to 0.1 ohms. So now the circuit and the switch is closed. Now that we know how this works, let's go ahead and build our digital inputs. Right, for our first digital input, we're going to use a configuration that I like to call pull up to 5 volts. So we're using a pull-up resistor, an external pull-up resistor, and connecting that to our 5-volt rail. We'll connect that to your Arduino A0 before the switch. So what we're going to see is when the button is not pushed, we're going to see a 1. When the button is pushed, we're going to see a 0. Now this is where we're actually going to recycle our code from our last example because we already set it up. So we have that we have this value set to 0. We have a pin mode. We put it as an input and as A0. And we have a value of digital read A0. Now we're going to serial print what that value is with a second delay. So let's see what happens when we push the button. Now when we push the button, it's saying that it's 1 right now. When we hit that button, it goes to 0. So it works. So if you're like me and don't like reading the colors on these to tell you what values are, most of them come with a printout that says 10K on there. If they don't have that and you don't want to go by the color code, you can use your multimeter to get that value. So I have one of those resistors hooked up and it's telling me it's 10K. So that's what we want. This next one, we're going to set our internal pull up on our Arduino. So instead of using an external 10K resistor, there's actually one that's built into the Arduino already. And that's pretty easy to use and specify. So in our code, on our pin mode configuration, we can just switch this from input to input pull up. That's going to make our circuit a lot easier. You'll have a wire that goes out to the button, and then the button's connected to ground. That's all you have to do. So let's compile this. No errors, and then let's load it up onto the board. All right. So it's reading at 1. When we hit the button, it goes to 0. So that's how that works. For this one, we're going to do pull down resistors. So we're going to get our 10K resistors out again and configure. And so we're going to have power that goes into the button. And then on the output of the button, you're going to have a 10K resistor tied to ground. And you're also going to have that A1 input into the controller. We'll go back to our sketch. And now we actually have to change this from the input pull up just straight back to input. We'll compile it. We'll upload it. Right. So if we take a look at the serial monitor, it's telling us what our input is. All right. So when we push this button, what we're expect to see is the output turn to 1. Oh. Okay, let's try this again. Wrong input. All right, switch to 1 when we push the button. There you go. And that works. You gotta make sure you set up your circuit right. You let it go and it turns to 0. So that's digital inputs. That's it for digital inputs. Pretty simple, pretty easy. So we did an external pull up to 5 volts, and internal pull up to 5 volts, and then we also did an external pull down. So you'll do an external pull up if you have a noisy system, a noisy circuit, or if you want to use another voltage source as your supply for that. Mostly in industry, that's what they usually do. So you can use both. The internal pull up for that 5 volt reference is probably like 50K or something like that. So it's more susceptible to noise. And so you have that pull down. So if you're interested in what a general introduction to microcontrollers, go ahead and pop that link. If you enjoyed the video, hit a like, subscribe, and share. And I appreciate you guys watching.